So in number 52, like in number 50, we want to find all of the real zeros of the function and find exact values whenever possible. Then we'll identify each zero as rational or irrational. So what we first do in this problem is come up with our list of possible rational roots. We write out the factors of the constant term over the factors of the leading coefficient. And this gives us the list plus or minus 1, plus or minus 2, plus or minus 4. After, with synthetic division, we find that 4 is a root. So let's do this together. So this shows us that 4 is a root of this polynomial function, and the coefficients of the depressed polynomial are 1, -2, and -1, which means we have this quadratic. So if we think about this for a little while, we see that we cannot factor this quadratic over the integers. So what that means is we want to use the quadratic formula. So I'm going to write out the quadratic formula for us. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we have that b is -2. So this is going to be 2 plus or minus the square root of b squared. -2 squared is 4. Minus 4 multiplied by AC. We have A is 1, C is -1, so that gives us this, -4AC, all over 2 multiplied by A. Then we simplify that. And that gives us 2 plus or minus the square root of 8 over 2. The square root of 8 is 2 root 2. So this is 2 plus or minus 2 root 2 over 2. And that simplifies to 1 plus or minus root 2. So this polynomial function has the rational zero 4 and then 2 irrational zeros, 1 plus root 2 and 1 minus root 2. So let's write out all of the real zeros in a list. So we have 1 minus root 2, then we have 1 plus root 2, then we have 4, each of these are irrational, and then we have that 4 is rational.